What is going on, calculus? Yeah, it's going to be that kind of a day. It's going to be that kind of a day. It's going to be an Eric Pride's call on me kind of day. Why not? Hope everybody had an amazing weekend. We're going to be doing a couple of things here. Big day today. Huge day in the day of calculus. This is going to be the day that we discuss average and instantaneous velocity. Now that may not seem like just a huge deal just yet, but it is going to be big for calculus. It's one of our main subjects that we're going to cover. There's a couple of vocabulary terms we're going to throw this way. It's going to be stuff you are going to hear from now until kingdom come. It's going to be everything from now until really the last math class you ever want to take. What's interesting is that you actually heard about these concepts first back in Algebra 1, way back when, years ago. You actually heard about these concepts. So let's discuss a few of them real quick. First off, average velocity. Now you may have said, well, Mr. Ballard, I didn't hear about velocity until physics or whatever. But you did hear about the velocity function, right? I've written it right up here. Kind of small, I'm sorry, but it's velocity is distance divided by time, or speed is distance divided by time. Now, for the sake of calculus, there is a big difference between velocity and speed. All right, we'll discuss that at a later time once we actually get into speed. But for us, right quick, the average and instantaneous velocity of something. This is going to introduce one of the biggest subjects that we're going to cover, and it's actually down here a little ways. So let's hit it real quick. If s of t is a function that describes the position of an object at time t, so a way to think about that would be to say s of t is your position. Position of an object at time t. Then the average velocity of the object over the interval is the change in position over the change in time. Think about velocity is distance over time, right? So the average velocity will be the change in position over the change in time. So you're going from A to B. You've got the position at A minus the position, or excuse me, the position at B minus the position at A over the time B minus the time A. Now that's a physics concept. It's very applicable to what we do today. So that's what the average velocity is. And the average velocity over any time interval, A to B, is the slope of the line joining the points on the graph corresponding to A and B. It's the slope of the line. Remember that it says s of t is a function, right? This guy looks really familiar. Looks very familiar, doesn't it? Think about your graph. If s of t is your function value, that's your y value. T is your x value. So isn't this really just the formula for slope of a line? And it's the slope of the line joining 2 points A and B. Well, that doesn't seem too much of a stretch, I don't think. This is the formula for slope. Average velocity is the slope between 2 points on a graph. Because we know that velocity doesn't have to stay the same, right? Velocity doesn't have to stay the same. Position doesn't have to stay the same. So this is the average velocity. Okay, so there's a difference between average velocity and instantaneous velocity. Instantaneous velocity is the slope of the curve at a point, a specific point. This is the slope of the tangent line to the given point. And it's also called the derivative of the function at that point. So there's a couple things I would like you to write down here. First off, it is the slope of the tangent line at a given point. Slope of the tangent line. And we know tangent means that it only touches once. Only touches once. Once is very important there. And it is called the derivative. See that word derivative? That is going to shape your future from now till Christmas. Derivative is the slope of the tangent line. It is the slope of the tangent line. Alright, so we have a little graphic down here. Get this down. It says that the slope of the tangent line represents the instantaneous velocity at x equals 1. So here's your graph. Back in the back here, you've got your graph, right? Here's from 1 to 3. So the tangent line is the instantaneous velocity at 1. How fast are you going at that instant? Well, I'm going this fast, right? And if your velocity happened to stay the same, then your graph would keep going up here like this, but it doesn't. It changes. Your velocity starts getting a little bit less increasing as we go up, right? Remember that this is position, this is not velocity. So your velocity here is getting slower as it's going up, the instantaneous velocity. The slope of the secant line represents the average velocity between 1 and 3. See, this is the average that you're going here. This is your average, right? So it may be steeper at the beginning, but eventually you're getting off that gas pedal, right? You're slowing down. So your average velocity is decreasing here, or your instantaneous velocity is decreasing here. It may still be positive, you're still going in the same direction, but it's decreasing so that your average is going to be a little bit less than your instantaneous. So you can think of it this way. If you were to lay a straight line on this graph, the spot where it would only hit once is called your instantaneous, and the average is your secant line between them. Now secant is what connects 2 points. Connects 2 points. In this case from 1 to 3. That's your secant line. Tangent line only hits once. So a lot of vocabulary coming out of the gate here, but just to make sure that we understand the concepts here, we put a little graphic on the back here. And I want you to remember something here. When we say average velocity, we are talking about the slope of the secant line. The secant line. The line that goes through 2 points. And if we're talking about instantaneous velocity, instantaneous, at that moment, we're talking about the slope of the tangent line. Alright? So we have a couple of things that we're going to look at. Notice we've got a little semicircle looking thing here. It's not quite a semicircle because it's a little bit taller than it is wide, but you get the picture. We have 3 points, A, B, and C, all labeled. Now if you think about the instantaneous velocity, at A, it's going to look something like this. Only touching once, it's going to be pretty steep. Then as you get to B, only touching once, see it's going to level out here a little bit. Still positive slope though, still increasing left to right. And then as you hit C, now your slope has become decreasing. Now it's negative. Now you have a negative slope. So think about the questions that it's going to ask down here. It says, draw the following and then put in order of least to greatest 1 through 8. Draw the following, put in order from least to greatest 1 through 8. Now really think about this here. You've got the average velocity of AB, BC, and AC. Then you've got instantaneous velocities, and you've got the number 0 and the number 1. And they want these in order from least to greatest. Let's go ahead and underline that just for kicks and giggles. Least to greatest. Well, think about this. As far as least to greatest goes, what numbers are going to be least? Very small positive numbers or negative numbers? Which one of those are smaller? Negative numbers are the smallest numbers you can have, right? From least to greatest. So what I want to know, comparing average velocity and instantaneous velocity at ABC, AB, BC, AC. Let's go ahead and draw some of this stuff in here. I've already drawn the instantaneous velocities. The average velocity from AB, oh gosh, that's not pretty. The average velocity from A to B is going to be this guy here. The average velocity from B to C is going to be this guy here. The average velocity from A to C is going to be this guy here. So a lot of stuff drawn on here. Let's think about this. I have a positive slope here at A, positive slope at B, positive slope from A to C, right? And then I've got a negative slope at C, a negative slope from B to C. So let's think about these. Which one of these is the smallest? I know it's got to be one of these two negatives is the smallest, B to C or at C. Which one has the smallest slope? By smallest, I mean most negative. B at C, right? This is the steepest downhill line that we have. So the instantaneous velocity at C, that is the least amount, that is the least among my slopes. Because this is negative, right? Alright, now you could actually go through and if you wanted to, you could put numbers on this. If you look at the slope here, it's from here, it roughly at C, it goes from this point to this point to this point, right? It pretty much goes through these points. I could almost call that down 1 over 1. I could almost call that slope -1. From B, looks like I'm going down a half and over, oh, just for kicks, let's say 2. So that's like a -1/2 here, right? So the average velocity from B to C is going to be my next one, 2. Now think about this. You go from negative to negative. What's in between the negatives and the positives? How about the number 0? Remember, we went from negative, negative, now we go to positives. Now I need the smallest positive that I could get. The smallest positive. If you look at A, right, the slope for A, here it is, it's going to be, it looks much steeper than 1. To be 1, it would be up 1 and over 1, so A would actually be this way. So it's much steeper than 1. B goes from here to here. B is roughly 1. I mean, it's close enough, I guess. Then you've got A to B, which is actually much closer to 1. The question is, which one is the least steep? Which one is the closest to 0? And honestly, I'm going to be looking at something either B or A to C. B or A to C. So going through this here, what I would say is that A to C is less steep than B is. So I'm going to go down here and I'm going to call A to C number 4. And I'm going to call the instantaneous velocity at B number 5. I'm looking at less steep to most steep. All right. Now from here, A to B, to me it looks like it could be greater than 1. Remember, this is mainly just an exercise in least to greatest, right? So which is steeper, the instantaneous velocity at A or the average velocity at AB? Here's your average, bam. Here's your instantaneous. The instantaneous at A is much steeper. So I'm going to call that 7 and 8. Alright, so bring this to class tomorrow. We're going to have an exercise on our homework. I'll start at the beginning of class on labeling slopes and really looking at what's greatest, what's least, and how to go from